Hi everyone, I am Alena and today we are going to do a training video on electrodeposition. Electrodeposition uses electric current to create a metal coating on a conductive surface that is immersed in a solution containing a salt of the metal to be deposited. It is a great tool for your materials design and particularly for the fabrication of magnetoelectric materials, like for example porous magnetic alloys with a pore diameter just between a few nanometers to microns, or magnetoelectric nanowires. And also you can combine electrodeposition with photolithography and nanoimprinting techniques. So in this lab demonstration we are going to grow a thin film of nickel on this silicon chip metallized with copper seed layer, and we will also deposit nickel stripes using this pre-lithographed substrate. To begin, let's prepare our nickel plating electrolyte. We are going to dissolve 13 grams of nickel sulfate, 3 grams of boric acid and 50 milligrams of saccharin in 100 milliliters of milk water. Anything you add in your bath will play a role in electrodeposition, and remember, the pH of your solution is crucial. You can adjust the pH with an acid or a base. Now, when the electrolytic bath is ready, let's prepare our working electrode by degreasing it in acetone. We will then rinse the sample in ethanol and ionized water. We will now cover a part of the sample with a Teflon tape to define the area we want to deposit and also to protect the alligator clip from the electrolyte. Next, let's assemble the cell. So we are going to using this single compartment double jacketed cell. So I pour the electrolyte in and I will control the temperature with a thermostat. We are going to use a platinum wire as the counter electrode. Then silver chloride as a reference electrode. And we will use our silicon copper substrate as the working electrode. We will introduce it later when the conditions are already set in the software. And we will also change the hydrodynamic conditions by using magnetic stirrer. Now, when the cell is ready, we are going to define electrodeposition conditions, that is voltage or current that will be applied, and the time. So for the continuous nickel layer, we will do galvanostatic electrodeposition, that is, we will be applying a constant current of 8 milliamps, that corresponds to 40 milliamps per centimeter square, the current density, and we will deposit for 120 seconds. That will give us a thin film of about 600 nanometers thickness. Now we are ready to insert the working electrode and press start. During the experiment, the current primarily occurs between the working and counter electrode, while the potential at the working electrode is measured with respect to the reference. So when the power is turned on, the working and counter electrodes gain charge. So our working electrode is polarized negatively. So all the positively charged ions from the electrolyte will be attracted there and then reduced. So nickel 2 plus ion will be reduced to nickel 0 and deposit on the working electrode. All the negatively charged ions from the solution will move towards the anode, towards the positively charged electrode, and will be oxidized there. And here is our nickel layer. Now we are going to do one more experiment, but using a prelithographed substrate. In this case, nickel will be only deposited inside the holes because the other parts of the substrates are covered with a photoresist. And I'm going to do a potentiostatic electrodeposition because I don't know what is the total active area of my working electrode. And then after electrodeposition, we can effectively remove the photoresist in acetone, and this is how our sample looks like after we did the liftoff.